I'm Dr.M.Meenakumari, Professor, Department of ECE. So today we are going to see about the architecture of 8086 in the paper Microprocessors and Microcontrollers. So what are the objectives of this? To define the microprocessor. What do you mean by microprocessor? So infer the different registers which is available in the 8086 microprocessor. Next, to discuss the functions of two blocks, execution unit, bus interface unit in 8086 microprocessor. Next, what are all the outcomes of this lesson? Illustrate the function of execution unit and then bus interface unit in 8086 microprocessor. So what do you mean by microprocessor? Microprocessor definition we are going to see. So it is a program controlled semiconductor device. It is an IC. So it is a program controlled one. It fetches the instruction and then it executes that one. That is the definition of this one. So it fetches and decodes what are all the functions we have to do. That one will be comes under the decoding section. Next one is it will now execute that one and stores the result. So your microprocessor is a CPU. So we are seeing in the laboratory CPU. That is the CPU is the microprocessor. So we will see the block diagram of 8086 microprocessor. 8086 microprocessor is a 16-bit version of microprocessor. Your data bus is 16-bit, so it is named as a 16-bit processor. Address bus is 20-bit wide. So your microprocessor now transfers the information to the outside world through the buses. Three different buses are, one is a data bus, address bus, another one is a control bus. So your data bus is of 16-bit in 8086. Address bus is of 20-bit. So how many memory locations it can access is 2 power 20. That is 1 megabytes of memory it can access. That is the main important specification of 8086. It consists of two blocks. First one is the execution block. Another one is next block is the bus interface unit. So bus interface unit now fetches the instruction and then it will be from the memory or IO. It will now Q is available here. 6 bytes of information can be stored here. So it fetches and give it to the execution unit. So that is the function of bus interface unit. And the execution unit consists of arithmetic and logical unit. Mainly it will done the execution of all the operations. So it will be now bus interface unit and then another one is a execution unit. So its architecture consists of many registers, general purpose registers which is of 16-bit wide. We can split some general purpose registers into the 2 8-bit wide. So what are the registers which is available in the execution unit and bus interface unit, we will see. So from the block diagram we can find out in the right side is a bus interface unit. So what is now here? So one is a segment registers. Segment registers are available in the bus interface units. So code segment, CS, code segment, data segment, stack segment, extra segment. Your memory already I told 1 megabyte of memory is divided into the many segments. So here each and every one of 256k byte. So 4 segments are there. Next one is a instruction pointer IP. It is also available in the bus interface unit. So what are all the function of instruction pointer is It will point out the address of the instruction which is to be executed next. So next instruction the processor should know, because in the main instructions some branching instructions will come. So we have clearly defined what is the address of the next instruction it has to branch. That is loaded in the instruction pointer. So we are dividing our memory into the 4 segments. So corresponding to that one, 4 segment registers are there. Next one is a instruction pointer. Instruction queue is available here. So 6 bytes of instructions we can store here. Next one is a bus control logic. Bus control logic is also available in the bus interface unit. So it will fetch us and then give it to the execution unit. So we will see some registers are mentioned here. What are the general purpose registers? AX, BX, CX, DX. These are all 16-bit registers. 16-bit registers. Another one is a pointer registers are available. Stack pointer and then base pointer. 2 index registers. DI, destination index, source index is available here. Index registers. So what is the function of this base registers, this pointers and index registers is, so it is helping to find out the 20-bit physical address of the instruction. So your address bus is of 20-bit. 20-bit we have mentioned in the block diagram, address bus is 20-bit. So it will convert to conversion from 16-bit address into the physical address of 20-bit. We need these pointers and index registers. We can divide that AX into the 2 registers of size 8-bit. One is called as a AH, higher order bits of this one. Another one is a AL, lower. So we can divide 16 bits into the 2 8-bit registers, which is named as AH and AL. So in the program we can use AX itself. Otherwise for 8-bit data fetching we can use AH or AL. So in the same manner we can use it for BX, CX and then DX. So these are all the registers which is available here. Another one is main important one is here ALU, arithmetic and the logical unit. It performs the logical operations, arithmetic operations. We all know the arithmetic operations. Example is here addition, subtraction, division, multiplication. Example for that one. Next one is here logical operations, logical ANDing, ORing, XORing. All that one comes under that category. So these are the block diagram of this one. So what is the execution unit, main function of this one? So it will just execute what are the instructions which is fetched by the BIU, bus interface unit. What is the function of bus interface unit is here, fetches instructions. Instructions, suppose move. So what are the instructions? Some data transfer instructions, loading the data, moving the data. So all that one just instructions, but in order to execute the instructions, we need the data. Data is, we can take the data from memory or IO devices. From the memory we can fetch it. And then our input devices or from the output devices we can fetch it. So your bus interface unit fetches the instruction, get the data from the memory or IO, and then after giving the instructions all data to the execution unit now performs the operation. These two are separate divisions, parallel operations. It will perform, execute that instructions, it will fetch that one. After execution unit gives the output to the bus interface unit. Through the bus interface unit, it is stored in the memory or IO. That is the function of this. So again we are giving this one. So what is the function of what I have given here is, so what are the different types of interface units, what are the different types of registers, so all this one. So we have to write your instructions. So addressing modes are available. We have to mention your instructions. We can group instructions in the different addressing modes. After that one, you can write direct addressing is there, indirect addressing is also there, indexed addressing is also there. So different types of addressing modes are available. We can now group the instructions into the different addressing modes. After that one, we can now execute the instructions. So the category of instructions, classification of instructions is that. So we can classify the instructions into the data transfer, arithmetic instructions, arithmetic and logical instructions, all that one, branching instructions. So branching instructions it will play a very important role, because by using this architecture we are executing the instructions. Each and every one is a different sections, but what will be that one is here, you have to execute these instructions by using the ALU, fetch the required data from the memory. Microprocessor is simply a CPU. It is a CPU. There is no timers, there is no memory available which is in the microprocessor. So microprocessor is different from the microcomputer. So microprocessor is different from microcontroller. Microcontroller inbuilds all these features: memory, CPU, timers. So for interrupts it's available. But in order to externally connect, in order to interface with the external world, we have to use external peripheral devices for this microprocessor. Peripheral devices, with the support of peripheral devices only, we can do connection of from this microprocessor to the external world. So timers are required, and then interrupts, separate interrupt controller is available. Ports are available. Port to separate IC is available. 8255 IC is available. So it has 3 ports, port A, B, C. So we have to give the data and then get the data through the ports only. So this is the main important. So in this class we are seeing the only architecture of 8086 microprocessor. It's basically of 16-bit processor. What are all the important registers which is available here? One important one is here, stack. So stack is the other one important one. Instruction pointer, already I have discussed, it will store the address of the instruction which is to be executed next. So stack is a temporary storage device. So here stack pointer is there. So we have stack pointer hold the address of the top filled stack. Stack is a temporary storage device. So for temporary purpose we can use the stack. The microprocessor will fetch the data from the stack. Suppose for example, if it is branching to some other instructions means, so main program, what is the next instruction address which should be stored in the what is stack pointer hold that address, because main program is the subprogram is also there. Branching instruction now branches to that program, subprograms. Return statement is in the subprogram. So after the return instruction, it has to now come to the main instruction. So what is the address of the instruction which is to be executed next in the main program is stored in the stack. push is the one instruction which will now pushing the data into the stack. Another one, after branching is over, now it executes the main instruction. Now we have to use pop instructions. So these pushing and the popping are the two instructions corresponding to the stack. So it will pop out, it will take out that address. That address is now stored. So stack pointer hold the filled stack address. So based on the instructions pushing and popping, your stack pointer is incremented or decremented. So these are all the main important data we can collect from the architecture of this one. So mainly we have studied about the characteristics of what is the specification of 8086. It is a 16-bit processor. And then what is meant by processor? It is called as a CPU. And the next one is here. What is the size of the address bus? What is the size of the memory? 1 megabyte of memory. It is arranged in the different form, stack, segmented form it is available. And then what are the main two units which is available in the 8086? One is the execution unit, another one is a bus interface unit. What are all the registers? 16-bit registers which is available and 8-bit registers which is available. What is the function of each and every registers? So general purpose registers are used to store the data. AX, BX, 16-bit data. You want to store the 8-bit data means you can use AHAL. And then what is the function of each and every one? So that is the main important thing. So here 4 segments. So this is the concept map of 8086 architecture. So it consists of 2 units I have shown here. One is execution unit, bus interface unit. So through the bus interface unit is having the buses. Through the buses it will now interact with the external world. What is the execution unit? Consists of main important one is ALU and what are the registers which is pointer registers, index registers, general purpose registers available here. This is the concept map. I am showing the concept map of this 8086 architecture. And the next one is a bus interface unit. So what are all the registers which is available in the bus interface unit? Segment registers, pointers registers, IP comes under this category. Another one is a instruction queue comes under this instruction queue. 6 bytes of instructions can be queued. We can store 6 bytes of instructions and then give it to the execution unit. So what are the references for this one? So here this is the reference book and then website. Thank you.